Okay, we're going to do a problem from the UT homework, courtesy of the UT Quest system. It says a particle travels horizontally between two parallel walls separated by 18.4 meters. It moves towards the opposing wall at a constant rate of 6.8 meters per second. Also, it has an acceleration in the direction parallel to the walls of 1.9 meters per second squared. What will be its speed when it hits the opposing wall? Okay, so looking at this, it doesn't look like the type of two-dimensional projectile motion that you're used to, but it still is. Just because it's not something falling through the air and being affected by gravity doesn't mean it doesn't work out the same way as one of those projectile motion problems. It's not a projectile per se, but it is working in two dimensions. And so because of that, we're going to solve it just like that. See, because it's moving in the horizontal direction, the x direction, but it's also moving up here in the vertical or the y direction. So as such, we're going to set up two tables, the x table in which we say to the right is positive, and the y table in which we say up is positive. So we'll fill out our variables for the x direction, and we'll fill out our variables for the y direction, and then let's go identify any that we have or any that are implied. So looking at this, we're going to say it starts at the initial position 0. So x naught is 0, and it's going to move 18.4 meters away, which means my x final is 18.4. In the y direction, again, we're going to say it starts at initial position 0, and it's going to move some distance up this way. I don't know what that is. As far as the velocities go, it says that it has a constant rate of 6.8 meters per second towards the opposing wall, so that's how I know it's my horizontal direction. And because it says it's constant, that tells me that these are equal. It's just a coincidence that it's equal the way horizontal motion is the same in a projectile problem. It's just because it tells you here that it's a constant rate of 6.8 meters per second. And of course, because it's constant like that, just like with one of those projectile motion problems, the acceleration is 0. Of course, I don't know time. I'm not given time, but I will be able to calculate it. Going over here with my y direction, I know that the initial velocity in the y direction is 0. And then it's given this acceleration of 1.9 meters per second squared. So I don't know what the final velocity is, but I know that that is the acceleration in that y direction. And again, I don't know time, but we'll be able to calculate it. So ultimately what the problem wants me to find is this final velocity when it strikes the wall. How fast is it going? Well, it says speed here, but we're going to actually calculate the velocity, meaning speed with direction. And so I'm just going to redraw this down here. It wants this final velocity, and so that means that I'm going to have my x component of that and a y component of that. And of course, we already know the x component is 6.8 meters per second, but I don't know what the y component is. So that means I'm going to have to go and solve for it. And so if I'm going to solve for it, then it's going to, I'm going to need time. I don't have enough information in my y column yet in order to find Vy. So I'm going to have to find time, and I'll have to find time from the x direction where I do have enough information. So looking at the equations, what you're going to need is one that has time in it. So of course that means that the first two, it's going to be one of the first two, and the first one, this second term here, the axt, is going to end up canceling out since acceleration in the x is 0, and it's just going to end up telling you that 6.8 meters per second equals 6.8 meters per second. True, but not useful. So really it's the second equation here that we're going to want. So I'm going to write it down. X equals x naught plus vx naught times time plus 1/2 ax multiplied by time squared. And like I said, this entire last term goes away since acceleration is 0. And of course, x naught is also 0, so that goes away. Leaves you with a very simple equation that says x, which is 18.4 meters, is equal to vx naught, which is 6.8 meters per second, multiplied by time. So of course, to solve for time, all you have to do is divide both sides by 6.8, and so you'll get 2.71 seconds. Okay, so now I'll be able to fill that in my table, 2.71 seconds in the x and y directions. And so now in my y column, I do have enough information. I have all the information I need in order to calculate Vy here. So what I'm going to do is I'm going to use this equation, because this equation, first of all, has a Vy in it. I don't have that option with the second equation. And the first equation, I don't know y final, so I wouldn't be able to plug in that term here. So this first equation, which is the simplest anyways, is what we're going to use. And so Vy is what I'm looking for. Vy naught is 0, and then Ay 1.9, and time I now know is 2.71. So Vy is equal to that Ay, which is 1.9 meters per second squared, times that time, 2.71, which gives you 5.15 meters per second. And so now we can go ahead and put that down in our triangle down here. And so now it just becomes a Pythagorean theorem problem. You know, two sides of a right triangle. So a squared plus b squared equals c squared. Or velocity final squared equals 5.15 meters per second squared plus 6.8 meters per second, all of that squared. And so if I calculate all this, and if I want to solve for v final, of course I'm going to have to take the square root of both sides. And once you calculate all that out, you're going to get 72.8, and then a meter per second squared is going to be a meter squared per second squared. And then once you square root that, of course, it'll give you a meter per second, and it's going to end up being 8.53 meters per second. So that's the speed it's going when it hits the wall. It's going 8.53 meters per second. That's the magnitude of the velocity, the speed when it hits the wall. We might also want to know at what direction it hits the wall. So what's the angle that it strikes the wall? The angle that that particle makes with the wall when it hits the wall. So I'm looking for that angle right there, which of course in our triangle down here is just this angle. So based off of that, I know my opposite side relative to this theta, my opposite side is 6.8 meters per second, and the adjacent side is 5.15 meters per second, which means to find theta, I'm going to use the inverse tangent. Remember, if you're finding theta, you use the inverse, and it's inverse tangent of opposite over adjacent, so 6.8 over 5.15. And so make sure you are in degree mode, and if you do, you'll get 52.9 degrees. And that's it. Not such a bad problem, huh?